Well, welcome to the last session. You guys ready for a nap? So I'm going to talk about the cloud, our friend. My background is that I started my cybersecurity career in 1992 at a place that actually has mission critical, not office critical or accounting critical. And I'm too far from the mic. All right. I ran my own company, and we started specializing in cybersecurity in 1996. Let's just say I was early. Started selling CheckPoint in 1996. CheckPoint started in 1993, and they're the commercial inventor of stateful firewalls. CheckPoint's the largest security pure play in the market now. We won't talk about the recession of 2008 that put me out of business. And since then, I've been working as a consultant. And then in 2015, I joined CheckPoint because I needed regular income. Consulting stuff was really interesting. I got to do some very interesting projects, mostly in the utility space. Okay, so this is how normal people see the cloud. It's pretty. It's safe. This is how cybersecurity people see the cloud. Not a safe place. Very dangerous. And the reality is the cyber war is just raging in the cloud. It's just a lot less visible because you have no visibility into the traffic. And the free accounts don't help. One of the problems is that they've automated the ability to create free accounts. The bad guys have automated the ability to validate that account, and then they go hunting. So their investment to go look for stuff in the cloud to attack is like zero. They don't need to own any hardware. So let's take a step back and let's review how we got here. 1993, there were 50 servers in the World Wide Web, according to Wikipedia. Well, at that time, you hooked up to the web, you used a router, and you hooked up to the World Wide Web, and you were good. And then we said, well, we should probably control who should come back in. So we put access control lists on the routers. And that was cybersecurity in the early 1990s. That's all we had to do. And then it came stateful inspections. Well, let's see what they're actually doing and where it's coming from. And so we started needing more control. And we started getting things like worms and network-based that could go out and replicate and get through the network. And then we added the ability to connect to Active Directory or LDAP or any of the other user access controls. So we could control that access to the World Wide Web and from the World Wide Web based on our user communities. Simple enough, right? Oops. So then we said, well, we really need to know if we've been hacked or we got stuff going on. So intrusion detection came about. Well, then that was approved upon with intrusion prevention. So we went from detection to prevention. And then we had the ability, we needed to look at sandboxing. We needed to deal with the zero-day attacks. And so these Trojans and stuff that were coming in via documents and all this sort of stuff with embedded code in it, whether it was a Word document or a PDF with code in it, we added sandboxing and zero-day detection. Well, that's pretty good, the detection that I should say, hey, about an hour ago, you got a bunch of stuff in your network that's really bad. So that turned into zero-day prevention, which is where your internal security in a lot of environments are now. So the whole concept of defense in depth that you're using inside your organization now with multiple firewalls and various trust levels has taken us 25 years to build. We started in the early 90s, and here we are, 25 years later, and we have a pretty robust infrastructure inside your network. and it's pretty much taken for granted. And you're all using multiple firewalls and trust levels, right? You're all using that? So that your management of your infrastructure and your security is 4 firewalls away from the internet? Right? You're using, right? So we got 25 years of development, deployment, and compliance. And when it comes to cloud, this is really important. But this infrastructure that most organizations have some form of now internally has been developed, and compliance is used to getting the reports, whether it be for HIPAA or PII protection or for PCI for banking or NERC-CIP for the utilities. This infrastructure allows us to demonstrate compliance, that we are meeting our cybersecurity goals. It's one thing to say this is our policy. It's another thing to demonstrate you've been able to execute controls, that you are abiding by your policy. So we've kind of come up with a way that, you know, before the internet there was antivirus, and that's your sneaker net diskette-based threats. So, you know, 100% of the people out there have that, right? Mid-1990s, we got firewalls, Gen 2 networks, threats. 100% of the people have firewalls. Most people have a firewall at home these days, right? So intrusion prevention, let's call that Gen 3 threats, we're down to 50% now. So that's 15-year-old technology now? Maybe call it 10 years old? Then Gen 4, which is sandboxing and antibot, you know, the botnets and all that sort of stuff, the whole zero-day ransomwares and all that, we're down to 7% in the internal networks. We got to change that number on the inside. So where are you on this list? Are you doing Gen 3s? Are you doing Gen 4s? On your internal network. Well, 2017, Gen 5 threats, which is now called Mega. It's because of the scale of the attacks. They're not point attacks, they're global. We got multi-vectored, they proliferate fast, they're cross-industry, they're large-scale, they use state-sponsored technology stolen from the NSA, and they cause colossal damage. These are Gen 5 threats. And here's the kicker. 99% of the successful cyber attacks in 2017 could have been prevented with technology that was available in 2016. And some companies had that technology in 2015. But most companies are 2 to 3 years behind on where they need to be in cybersecurity. And that's the challenge. How do you get there and keep current on your internal network? We haven't talked about the cloud yet. Okay, so along comes the cloud. Well, we got private clouds, we got public clouds, we got hybrid clouds, we got infrastructure as a service, we've got software as a service, and you got to secure all this too. In the cloud, how do you verify and log authorized users? How do you verify and log authorized content uploads? Because it's now out there. Who gets to put stuff out there on your stuff? And how do you authorize that? How do you revoke and log the removal of authorized users that are no longer authorized? How do you protect against Gen 3? How do you protect against Gen 4? And how do you protect against Gen 5 mega attacks in real time in the cloud? How do you provide protection for personally identifiable information, PII, in the cloud? How can you demonstrate compliance of protecting personal identifiable information in the cloud. So, we got this great development project. Let's put everything up there. Okay, well, what's in this data? It's got addresses? Yeah. It's got names? Yeah. Social security numbers? Yeah. Okay, well, how do we demonstrate compliance for protecting all that? That usually shuts down development real quick. Because they haven't had to worry about it because we spent 25 years building this infrastructure inside the organization. So in the cloud, we start again. And we do it with 1990s security. The vendors, the cloud vendors, providers provide you a virtual router with an access control list, and they call that security. Was that good enough now? No. Was it good enough in the mid-1990s? Yes. So we're going to secure the cloud with 1990s level technology. Really? So we have to build the environment that we're used to seeing. Okay, Gen 2, we've got to add stateful inspection firewalls with Active Directory integration for user access and logging. And we need to do intrusion prevention in the cloud, just like we do in our inside organization. And we got to do 0-day in the cloud, just like we got to do it inside. How do you do that in the cloud? And for the mega threats, you need to do the 0-day prevention in real time. None of it's there. You have to build it now. It doesn't come with your cloud environment. So the cloud is many things. It's elastic, it's cheap to start, but it is not less expensive over time. You invest in a data center internal, your cost curve goes down. In the cloud, the more you use it, the more expensive it becomes. In the cloud, as you break over thresholds, you want more than 16 processors. That's a higher price. You're using too much data. That's a higher price. We're having to store over 1 terabyte. That's a higher price. My own personal bill has doubled, and I'm not doing anything different. It's just that the storage is starting to creep. It's not cheaper over time. It's cheaper to start, but it's not cheaper over time. So it's many things. It's elastic. It's really good for companies that have very seasonal work. It's good for companies that can no longer build data centers because there's no space for it. It's good for companies that have their fear of their data center being blown up, and so they want to have a cloud duplicate for resilience, but it's not cheaper because you have to build the infrastructure we just showed you. The good news is all this is available from a number of very reputable vendors. The stuff to do what we just described that you've done inside is all available from the cloud. If you're working with a current vendor now, they have a cloud solution that can be managed probably with the same management you're using now. The difference in the cloud is it'll be distributed architecture. Instead of having a firewall that's a big choke for it with a 40 gig card in it, that's not how you do it in the cloud. You got to use a bunch of little chunks. You're limited to 2 or 3 NICs, and you've got the limit of the backplane in their environment, so you can't put a 40 gig choke point in there. So you have to distribute your firewalls. And you'll probably set it up to do it for each project. It will have its own little environment that has like 3 firewalls in it. You'll have numerous small gateways. You need to develop a plan on how you're going to do this. You're going to need to do a consistent methodology, and you need to have templates for your cloud environment. So you do it the same for all your projects. So if you're working on any one of the projects, you know how it's set up. Because the cloud, you can't go look, where does this cable run? You don't get that. You have no access to the layer 2. You got no blinking lights. You got none of the things that we're used to in the physical world to know how it's all connected. So your map that you develop on how you're deploying it is going to be real important 5 years from now, 4 years from now. You might be at a different job. So documentation on your plan, your methodologies, and everything, how you deployed this in the cloud, and consistency. You got to consistently deploy it the same way. If you do this one different than that one, then how do you support 2 of them that are different? You can't figure it out. And it's that kind of mistake that led to a very simple breach from a major telco. The guy just made the segment public in front of his web gateway, his web interface, made that segment public. Well, in the cloud, layer 2 can see all the other segments. So he made his whole environment public without realizing it. So when they were, quote, hacked, they weren't hacked per se. Anybody could see the server. So the only hack involved was getting credentials to the server to suck all the data off. And everybody that talked to tech support in the last 18 months for that customer, everything about their cell phone was exposed. Who they were, their address, their bill. So it's very easy to make simple configuration mistakes in the cloud. Now, if it had a firewall in place, even if it had an any rule and log, they would have seen all that data leaving. Gee, why is this thing so busy? There's nobody logged in. Well, gee, we got all this outbound traffic. So automation is very much part of the cloud. Ideally, your templates and everything that you've deployed, your methodology. So you have a new project, you take your templates, you plug in the IP addresses, and you deploy. So if you did your planning right and had the correct methodology, deploying the cybersecurity infrastructure is very straightforward because it's automated. You just push the button and it goes. You update the few IP addresses it needs, and it goes. And the use of the cloud is all about automated deployments. And that helps give you the consistency. Most of the security vendors in the cloud support automated scripted deployments. And that's really the recommendation of how to understand how to use the cloud well. Because if you use the same scripts to set up these environments every time, just change the part that changes, you're going to get that consistency. You need to get visibility in the network traffic in your cloud environment. Without any external cybersecurity tools, you've got no visibility in the traffic in the network. You got to be able to see the authorization of users. You got to be able to log the content uploads. You got to log failed logins. You can't get that information from their virtual router that they provide you. Well, how many people tried to log in and failed? You don't have control over that. And all this logging is necessary to be able to demonstrate compliance. And it all goes back to that. When somebody says, well, why do we need to do this in the cloud? How do you demonstrate compliance, sir? And one of the challenges that I've had is you need logs from the cloud vendor. And the best that we've been able to do, get them to agree that if there's an incident, they'll turn over the logs relating to your environment. But really, you should have logs when they access your environment. So in the event of an incident, you're going to need access to their logs too. And that gets back to contracts and making sure that you have access to those logs that were relevant to the incident in the event of an incident. Now, how do you pay for this? Well, really, each project needs to pay for the cybersecurity. If you use it internal, it's already been built for you and is free. You go to the cloud, you have to pay for it, just like you pay for processors and storage and everything else. You got to pay for your cybersecurity in the cloud as part of the project budget. Oh, well, gee, we can't do that. Then you can't do the project. The cybersecurity has to be there from the start. It's not an add-on. It's got to be the way you structure that cloud deployment. Just like you have to pay for processor storage, network I/O, they got to pay for security. Because without security, then nothing of the rest of it matters. It wouldn't be a trusted system. The data would be, who knows who put the data there. Okay, so most cloud vendors offer two kinds of licenses. The pay-as-you-go, which is great for setting up demonstrations, for playing around with it, for doing maybe small pilots, but you want to bring your own license for any production environment. It's licensed like any other firewall. It's just a subscription that every year you renew because it's a software license. Because firewalls are 24/7. It's not like they're occasional use, you only spin them up when you need them. They're there all the time and they're running all the time. So if you fire one up and leave it on in a 24/7 environment, it's going to get very expensive very fast. So keep that in mind when you transition from a development project that turns into a pilot, that turns into production. You got to relicense those firewalls. And in most of the environments, you can't change the licensing. Once it's pay-as-you-go, it stays pay-as-you-go. So you actually have to deploy a new firewall with the license. So you got to decide in your mind where that transition is going to be. Okay, I'm going to do my development with pay-as-you-go, but from pilot on, because the pilot will move into production, the pilots need to be the one-year licenses. Now, like from our company, you can do a 30-day eval license. So even if you're doing a development setup, you can select bring your own license and then go to our website and get a 30-day eval for it. So it would be a bring your own license, but it's only a 30-day license. So if you're trying to learn how it works or set up a development environment. Now, this is one that's probably fairly controversial. Your logging and your management needs to be external of the cloud, because your whole cloud environment can disappear in one click. Delete storage, boom, and it's gone. Well, if your management's in there, how do you restore it? How do you restore the security environment? And your backup really needs to be outside the cloud too, but that's a whole nother thing. And the last thing here is huge. Account takeover is the #1 vulnerability in the cloud. If you lose control of your cloud administration consoles from Azure, AWS, or any of them, you've got to use two-factor there. You've got to have the physical token, RSA tokens or any of those tokens, just like you would any other high security management system. Because that's the #1 way in. They do a phishing attack, they get your thing. In the case in England, when a company went from one of the top cloud providers in England to bankrupt in 12 hours, because they had scripted making admins and started killing passengers by deleting the storage. And of course, the cloud provider was saying, we're the most redundant, we got your data 3 places. Once you click that volume, delete, it deleted it out of all 3 places. So 64 other companies went bankrupt because nobody had their data backed up outside the cloud. And it was all because somebody got their credentials to AWS. It wasn't AWS's fault. You didn't control your credentials. Our best practice is they use two-factor. And that's not really a big expense. You can use the soft tokens from RSA in your phone for your management team as what, 10 people? 5 people? It's not like you're getting tokens for your whole employment thing. But if you lose control of your administrative console, everything you have out there is gone. All it does is right-click, delete, and your environment's gone. I can't emphasize that enough. Okay, so use your security vendor's references. And this is where I want to point. So we'll try to do it with this. Okay, so let's see. Go forward one. All right, so we got 3 firewalls here. We've got trust levels, just like you would in the physical world. This is a completely cloud solution. Nothing here is physical, but it's divided into trust levels. Note the use of small firewalls with 3 NICs each. And in Azure, it was only 6 months ago that we could put 3 NICs in the firewall. Let's see. Okay, so, all right, so here's where we want to stay. Okay, so this guy here, virtual load balancer, is where you would be able to duplicate the environment and have geographically different storage. And so from here in is the part that you guys do. So this would be your perimeter firewall and is in front of your web front ends. 1 NIC in, 1 NIC out. You're logging every traffic that comes through there. And we have a separate management network back to the main office. That management network could actually be also used to manage these servers if you put a second NIC in them. Same with here. So the management network is never exposed to the internet. Real important. So the traffic that's going from the internet to your front end doesn't have to compete with the traffic going through this firewall. Again, small firewalls break up the traffic into different stuff. So these, here's your database servers and your storage back here. Oh, always put your storage on a separate NIC. Don't let the storage share a NIC with the people accessing it, because you'll have contention on that card, so it'll be spongy. And then this third firewall here is the firewall that takes the management network and any connections from these servers back to your main office. So it's running the VPN traffic. So the load of that VPN and all the logging that has to go back to your organization goes through here. So it's not clogging up either one of these, the two main NICs here. It's coming through the management channel for the logging and then going back to the main office via the VPN. Now, in the physical network, this makes sense. We do this all the time. Well, why don't we do this in the cloud too? It's actually more important to do it in the cloud because we can't make these guys big. We can't put a 40 gig card in there and say, well, look, we'll just put a bigger card in there so we can get more traffic through it. You're limited to what they modulate your traffic between devices in. So you have to be very careful to balance that load out. So your SQL requests from these web servers back to your database aren't going through the firewall for the people that are accessing that website. Different kind of traffic. So you think about it so they don't have to compete, and that the storage is on a separate NIC on the servers in the back end of the database servers. Now you can break this up a number of ways. Let's say that, I'm pushing the wrong buttons here, sorry. Okay, so let's say that all of this is going to be in your physical data center. Well, then you just need the two firewalls. You need this guy doing the VPN back to the main office. But this is how you would simply do this from a typical standpoint. Now, we're used to doing clusters in the physical world. We do active standby clusters for redundancy. Well, we don't have physical hardware that's going to fail in the cloud. So you have to really think through redundancy. And are you going to duplicate this whole environment with duplicate storage? Are you going to duplicate just the web front end? Where's your single points of failures? Having clusters of firewalls in there doesn't help you if everything else is single threaded. Because if the firewall fails, you just spin it up again. It's just an image, clunk, and start it again. So a lot of people are doing clusters, and I will contend that that's really kind of a waste of money. Figure out a way to duplicate the whole environment in another geography and use this front-end load balancer to be the guy that decides which environment, or you decide which is active, but it routes to which one it's going to use. And then you got to work on strategies to keep the data replicated between the two environments. So cloud is simple until you start trying to get redundancy and all that kind of stuff in it. But the key point I want to make here is think about it in terms of many little firewalls. It keeps the route simple. It keeps looking at it simple when you've got to do diagnostics and stuff, and it gives you the logging at the different places you need. So you got authentication logging. You're not going to run all the, are you going to run the IPS at the front or maybe in the middle? You're going to run intrusion detection. I mean, there's different blades you would run on different sections. Okay, so here's a list, and this is on this Cyber Symposium website. And this is just kind of a start, but when you're evaluating solutions for the cloud, these are things you need to look for. You need the ability to use the server objects you created in the cloud environment's admin screen. You create a server in there. You need to be able to use that in your firewall rules. You can't use the IP address. It changes, it moves. It's like VMware when you vMotion something. It's got a different IP address. So you need to be able to use those objects in security rules, not IP addresses. That's ability to log cloud traffic external of the cloud, I think, is real important. The ability to serve objects in the logs, not IP addresses. If you're doing rules by IP addresses and they change, well, okay, that's not going to work. Okay, so if I got objects in the objects in the security rules, but I end up with IP addresses in the logs, that's going to be very difficult for compliance. You want the object name in the logs. So you got to be able to carry those server objects all the way through to the logs. So that's something to look for in your decision of what products you're going to use. The management system needs to be able to manage physical, virtual, and cloud security gateways in a single solution. You want to be able to use objects from AWS, Azure, VMware, and physical servers all in one rule base, because most people are going to have a hybrid situation where stuff in the cloud is talking to stuff in your physical data center. You want to be able to do that on a single rule. You want to be able to say this web server can talk to this database in the physical data center. Management needs to be able to use objects from different cloud providers. So you can use Azure objects and AWS objects and Google Cloud Services objects in your database, in your management, without having had to do anything different. That's something to look for in how you manage this, because you could see how if you have to use a separate management for AWS, a separate management for Azure, a separate management for VMware, and a separate management for your physical, that it would be very convoluted very quickly. So you need a single place to get all those objects together. And lastly, the security in your cloud, just like your physical, needs to be able to do Gen 5 threats in real time. You got to do the same level you're doing in the physical. The cloud is quite useful with cybersecurity that you control. If you don't have that control, it's not that useful. That's my pitch. Any questions? I'm sure you have lots of questions.
So with a solution like Wings Azure, for example, when you create the VPN tunnel back to your on-premise data center, you create it from your virtual firewall to your on-prem firewall?
Correct.
Go through the gateway?
Right. In our environment, it's seen as just another gateway. So it would be just like setting up a VPN to your branch office or between two major data center peers. And my contention is you got to take that load off of one of the other firewalls, because that's going to be more processor intensive, and you don't want to buy a 16-core processor just for that and pay for all the memory and everything else that goes with a server that size. So by breaking up the chunks, plus you can log that traffic just there and have that funnel all your log traffic from the other two firewalls through that. We work quite closely with Azure, and AWS has almost become, it's set in stone. They do it their way, and they were there first, and it's set. Where Azure and even Google, because they're newer kids on the blocks, they have worked with us quite a bit on how can we do this better. So there's better integration from the cloud, from the security people in those environments. We can do a lot of things in Azure. We can do all of this in Azure, and I will say that probably 60% of our customers are in AWS, because they have the market share. And our big companies that are doing this are already there. From my personal experience, I have found it easier to work with Azure because you have more routing control than you have in AWS. And so it's easier to get the routing to go the right places and not make the mistake where you open a segment and it can see the rest of them. Because the magic hand of layer 2 in the cloud, all those segments are not, they can see them all, whether they're networked, the segmentation that we're used to in the physical environment doesn't work, doesn't apply.
Yeah, one thing I've seen with the user-defined routes in Azure is it kind of can't even talk,
Right,
play with each other.
right. And I think with that, you're less likely to make a routing mistake, like I have made numerous in AWS. Microsoft has their own VPN, and what we have found for what kind of traffic that we're doing, it's better to use our firewall VPNs to firewall VPNs from a management standpoint and everything else. Plus, it's lower cost. You're not buying their piece of an MPLS line. And there's some routing issues that come up with their VPN solution. Anybody else? Want me to go back to the drawing and? So the handout is about a honeypot that we set up, and it was set up like you would do a normal server, but we didn't put any of our security in front of it. You know, it started being attacked in less than 15 minutes, and within 7 days, it's like 300 and something thousand attacks. And that's any server you would put out there that would happen to it. So the security has to be there from the start. All right, well, thank you, gentlemen, for sticking to the end here.